I will start speaking while my laptop is rebooting, since I did check that it worked just during the break. But of course, I did try some fancy stuff while the others were talking, and I broke something in the, I thought, a new bug. So basically, I'm going to present you what we have done on the OpenBSD side for the graphics. So for those who don't know much about the BSD, one of the main features about OpenBSD is that, and that makes it a bit different from FreeBSD or Dragonfly, is that we support a large set of architectures going from VAX, but not the one in the hall, to Spark machines, to PowerPC, Mac-based PowerPC machines, Silicon Graphics workstations, a huge number of different architectures. We have some advantages here because our console drivers and graphics parts, independently of X, are generally already supporting things like bitmap console, for example, which make the things easier to go to KMS, because instead of having the trouble to restore the text mode, we can just switch the x86 architectures to using a console, graphical console mode used on what the KMS driver in the kernel are providing. So one other big difference is that in OpenBSD, X is part of the base system and not of the port system. So we are providing a more regular integration with the system. And yeah, it works now. Just switch to a lower resolution, so that my so this is OpenBSD current running with Xserver 1.16.1, the MISA 10.2.7, and all the libs and so on upgraded to the latest versions. So yes. So that's what I've been explaining so far. And we have the port 3 for all the third-party software. We also have some very active porting of the GNOME and KDE desktop. GNOME is being sold by some third-party company which supports customers using the GNOME desktop for professional application under OpenBSD, and this company has helped us a lot for porting the KMS drivers. So in OpenBSD, we have the subsystem that is called Xenocara, which is the OpenBSD source tree for X. It makes it easier for people to look at what's there and and have a view of the complete system. So, like I started to explain it, we are trying to keep up as much as possible with upstream versions. The last status talk that I gave about this was in the X.Org dev room in FOSDEM 1.5 years ago. Since then, we have done a lot of updates. The Intel driver was just behind the door at FOSDEM, It's now been in the tree for 1.5 years. And the Radeon driver with KMS came something like 6 months later in the summer of 2013. Most of the work, porting the current Linux KMS drivers has been done by Jonathan Gray in Australia, sponsored by the MTR company. And among the other, the OpenBSD developers who have helped a lot with virtual memory integration and the console driver integration have been Mark Ketenis, and for earlier work, Owen Ainsworth. Owen or Oga on IRC has done a very nice start at porting all the virtual memory features needed by KMS and DRM to the OpenBSD kernel, and later Jonathan and Mark were able to reuse lots of things here. But also, on this slide, I want to say a bit about this philosophy of getting the Linux code with the least possible modification to the BSD. This is now also the way that we have been using with Jonathan, but it was not completely straightforward at the beginning. With Owen, we also started to try to adapt things to the BSD kernels because there are some interesting features which were already there in our BSD kernels, like support for probing modes of external monitors on Spark workstation or on Mac PPC machines. So there was already some framework in place. We have a I2C framework to get other sensors from the machine in place, and we felt it was a bit silly to duplicate the I2C stacks between the BSD parts and the graphics parts. But at the end, this is something that's more or less a dead end when you don't have enough manpower to do all this work. But there is a problem, is that all this Linux code that we are importing with as few differences as possible is not going to be reviewed by any of the other BSD kernel developers. This is one of the reasons why everyone started to change the style. For example, like François said, we did the same kind of mistake, perhaps, in OpenBSD, but this is because many of the other kernel developers just refuse to read any code that is not conformant to the BSD KNF standard. So converting the style more or less mechanically was something that we felt is important, so that the code gets more eyeballs, and when someone finds a problem, a bug, which may be related to to a real bug in the Linux code, it would be easier to have someone helping finding the bug in the BSD community if the code was formatted to the BSD standards. But as the two other speakers already said it, it's really not possible to maintain the code, mostly because the Linux code is still a fast-moving target, and so we cannot just look at the Git history and import the meaningful changes and the bug fixes just by comparing the Git history on one side and from Linux and the history from the BSD kernel on the other side. It's better to just import things more or less mechanically. OpenBSD, since OpenBSD has integrated X in the base system and supported many other architectures from the start, we have some extra features compared to standard Linux or other BSD X stacks. We support a few non-X386 architectures, as I already said, even under X. Our current KMS driver also work on Mac PPC and Spark 64, where for the Spark 64 machines that have Radeon cards. We have the WS console driver, which is different from the one used in FreeBSD and Dragonfly, which can work in graphics mode, which helped a lot for that. We have a specific input driver for devices connected to the WS console driver, which means that we don't use the mouse driver anymore on architectures, well, on our machines. We use the Synaptics driver for touchpads or the WS input driver for mouses, touchscreens, and panels. One thing that I did almost 10 years ago was the privilege separation code in the X server. You all know that having a large set of code running as root is not a good idea from the security point of view. So even though there are some issues with the privilege separation code, because the unprivileged part of the X server that we have been running still had access to the hardware registers of the machine, and there was a paper from Loïc Duflo at CanSec West in 2006 who showed the issue, but I knew about this issue before that paper. It is possible for someone who finds a vulnerability somewhere in the X server that allows him to inject code, to use the actual access to the hardware to do things with kernel privilege from the X server without too much trouble. Without too much trouble, except for the specific case that Loïc demonstrated. No one has ever managed to exploit that in the real world, so it was not that bad. And now that we have KMS support for Intel and Radeon cards, there is absolutely no access possible to the hardware registers anymore. So we are effectively running the X server privilegeless. There is just a small part, a small process that stays with root privilege that is used when we need to have root access to open devices, mostly when you switch back and forth from X to a text console. X closes all the input drivers when it switches to a text mode, to a text console, and when you switch back to X, you need to reopen these devices, and some of them may not be owned by the user running X, specifically when you use a display manager, because then the unprivileged user used by the X server is some generic user and not the UID of the user running the X session currently. We also developed a specific window manager, but in the times it's a small decoration-less window manager which tries to implement all the modern NetWM features and filled a gap that to be in the OpenBSD base system, it needs to only depend on BSD licensed libraries. So it, unfortunately, that rules out most of the other existing window manager. In the base system, we also ship a very old version of FEWM. But some developers are really conservative about that and really like this old FEWM, so we cannot get rid of it. Some small thing that was done recently by Mark is to enable the use of the new MIT SHM API using the passing of file descriptors to access the shared memory segment, rather than having to pass the actual shared memory descriptor from the userland program to X. This solves the issues with the access right to the shared memory region, where there are a number of possible vulnerabilities. And the way Linux does it is to have a signal handler in the X server that is there in the case where the user who originally created the shared memory segment decide to truncate it or to close it completely. And then whenever the X server would try to access the data in this shared memory segment, it will cause a SIG bus on Linux. On OpenBSD, it actually caused a seg fault. So we would have to patch the server a bit to also catch the seg fault. But more importantly, our kernel people said, well, this is not really robust, and people may forget to do that if they want to use the same kind of API in other subsystems. So let's try to make something that will allow to have memory mapping that will never fail. And if the user truncates the memory mapping, the X server will just get empty zeroed page from anonymous memory. And so the patch in the X server is just to map the memory segment with the current map no fault flag, so that those mappings are not going to fail.
So you get no notification that the mapping has been destroyed?
If you no, you don't get any notification that the mapping got destroyed if you don't need it.
So one of the nice things, one of the nice things we had in Linux was when you get that SIG bus error, we actually in the shared memory code we actually destroy the object, so that if the application then comes and tries to create a new shared PIX map out of that same segment, you actually get a bad value error back to the application. So the application knows that that segment has been destroyed, and the server can actually send errors back to the application that something bad has happened. So this is really nice in terms of not having to do the SIG bus handler, but it provides a little less error detection.
Yes. Since I've not found many applications that currently use the new API, we've not been able to really test how it's working and if there are some issues.
Well, the applications aren't going to do this. Aren't going to a good application won't do the truncate anyhow. So.
Okay.
But the nice thing about if the application accidentally truncated the file, then at least you would get an error and the application would crash instead of just having the wrong date on the screen. So that was one of the nice things about the SIG bus hack.
Yes, sure. I was thinking about that and said, well, for other cases, if you don't want this behavior, you can still not set the flag when you call mmap. It's not on by default, and then you will get the old behavior. Even if it's knowing if it's better to have SIG bus or SIG SecV is probably just a matter of taste. So, and this is really recent, from the 3rd of October. So we still have, even if François said that OpenBSD has the best support for KMS among the BSDs, which I think is true, we still have some missing parts. One of the currently annoying things is that we don't have LLVM in the base system, so we cannot build the MISA Gallium drivers that require LLVM. Hopefully this is something that's going to change in the near future, because we want to replace GCC by LLVM as the base system compiler as soon as possible. We've discovered that MISA always likes to depend on the very latest LLVM, so we may end up having 2 LLVM versions in parallel, one stable one that is able to build all the system, and the bleeding edge one used by MISA for the pixel shaders. Something that we also still miss in the pthread systems in the libc is proper support for thread local storage. So I know that it has some impact in Pixman, but there are fallbacks for using the old API with application-specific data. I don't remember exactly how it works, but we can work around this in Pixman because the code is still there in Pixman. If you don't have TLS, I'm not sure that a recent Mesa version will not be causing us problems. But this is something that is planned to fix at some point. We also don't have any way to implement the new XSSM fence API for now, but this is also in the works. In a couple of weeks or months, it should be fixed. We don't have multi-touch support because basically we have our own input driver stack and have not yet planned anything to go to EVDev really. There are some discussions internally in the project, but given what we've seen with the output part of the SAC, I think for input it's going to be the same. We are going to get as most Linux compatible as possible, perhaps at the lib input level rather than the evdev, because it seems a bit easier for us to implement a lib input backend over our input drivers than to re-implement evdev completely. We don't have Nouveau, basically because for years we have said OpenBSD users don't buy any NVIDIA graphics because they are not supported. So now it's difficult to find a developer with Nouveau hardware that is going to try to port the drivers. But given that we have all the necessary support from TTM, I think it should not be too hard now to get the Nouveau code in the tree and have it working. But none of the other BSD has done it yet either, so it's difficult to say if it's difficult or not. And all the issues around the increasing integration of X with systemd or Wayland. For the support, for the future work, we are still based on the Linux 3.8 stable stack, but given that we have minimized the differences with Linux stack, it should not be too hard to upgrade to newer versions, and this is in Jonathan's plan in the coming months to update to a newer Linux kernel version of the drivers. As I said, we want LLVM as the base system compiler, and then we will be able to build more of the Gallium drivers natively. Do something about input driver. We have had this GSOC project about implementing systemd login compatible daemon. We will see how it will get integrated into the system, and probably help with running GNOME or other display manager more in the way that Linux does it, as already told us about Nouveau. Among the difficulties, we would like to import some of the other KMS drivers that exist in Linux, like Matrox or the one for AST cards, but unfortunately some of them have switched to GPL only license and not to the dual MIT GPL license that is on the rest of the Linux graphics card, graphics stack. So it's a bit annoying. I know that Jonathan has been in contact with a few of the Linux developers of this driver trying to get the license to change, but I don't think he managed to actually get an okay to dual license those drivers yet. So this is something ongoing. And as I already said, all from my point of view, all the motion to Wayland, systemd, and so on makes the Linux slowly drift away from the traditional Unix model for a number of things, and this is making many of the BSD users uncomfortable, and it's difficult to see how we are going to live with that in the future. If we are following exactly the same path as Linux, because we don't have enough manpower to invent something else, or if we will be able to attract more developers who want to try to make something that perhaps less advanced in some areas, but at least will make people who are attached to the traditional way of doing things in Linux more happy. And that's it for my presentation. So if you have questions, Ajax.
So when you say the traditional Unix model, I'm curious what you're actually worried about there. The X server doesn't require Wayland, is probably never going to. The X.Org server, which I'm still going to have to maintain on operating systems that are never going to get Wayland or systemd, is moving further and further towards a model where there's not even drivers, where I have mode setting and Glamour, and so the X server doesn't have any actual dependency on Wayland as a display system, and X.Org is not going anywhere because I'm not going to be able to stop supporting Rel 6 for, yeah, like 5 or 10 years. The X server doesn't depend on systemd. That cannot possibly depend on systemd. This really, I appreciate the concern, but it seems like this is and also to be fair, the traditional Unix model had graphics drivers in the kernel.
Yes.
And the x486 model was actually a rejection of that in the name of portability across multiple Unices, which is, you know, sort of a false economy. So while I definitely appreciate the concern, I think this is really just saying, God, I hate systemd. Can we make sure that we never have it in BSD because we want to make sure that we're still writing shell scripts forever? If you have actual problems, please do raise them.
For now, we don't have any specific problems, but I just, well, some people, because I'm not sure I share this completely, but some people really fear that at some point it will be the only way to start the X server will be from systemd or things like that. I know that there are some other Linux distributions that need to start X.Org the traditional way, so it's not going to happen soon. But
I mean, there's like if you look at how OS X starts the X server, it's been a slave out of launchd since 10.3, maybe a little bit earlier. When we added support for that in X.Org, we didn't rip it away from anyone else. I'm pretty sure Solaris is not going to ever be able to launch from systemd, because when are they going to change their init system? Like, it's
no, and even
it seems spurious is all.
Well, personally, I even think that some of the features from systemd are really interesting, and that there are really things that the traditional Unix model does not handle correctly. When you want to have some multimedia system where you can plug extra audio outputs, things like that to the system and get that configured and running automatically, and it's very, very difficult to handle that correctly in the traditional way. So I'm not, personally, I'm not completely convinced that we should not change the way things are done. But when we talk to our users on the mailing list or at BSD conferences, there is still a lot of people who don't really get that. And I don't know how we are going to manage that in the future.
The one other thing was on the TLS part of Mesa. You don't need it.
Okay.
It's a cool performance optimization for when you do have multiple threads, that you can allocate the dispatch table and the context pointer in per thread space, and then look them up with basically a data relocation instead of having to do a function call. But that's optimizing for GLX gears in software. It's not a huge deal on most modern applications if you're trying to run actual games. So, you know, make it work, please, because TLS is a thing that ELF should support, but you don't need it.
There are also lots of third-party applications in ports that require proper TLS support, so we are going to do it anyways. And
yeah, you can build Mesa without it, and as long as your Mesa doesn't assume it, you'll be fine.
Okay. So, and about the question about performance, I don't have any actual numbers to show, but I know that globally the graphics stack on OpenBSD is still slower than on Linux, but it's also mainly because of general issues. The system call overhead is much higher in OpenBSD than in Linux and other things like that. But we have fixed a number of issues in the virtual memory system that makes that, for example, that now Firefox is really, from the user point of view, as usable on OpenBSD as it is on Linux. For years, we have had some problems because Firefox is really, really pushing lots of graphics data to the X server, and then the X server